Rules of integration. These 4 rules stated here are used as a guide to actually integrate the functions in the coming few slides. So for example, if you have a to the power of x, ax to the power of n, you actually integrate it such as a is a constant, leave the constant alone. Your focus is to integrate x to the power of n. So you actually increase the power of n by 1, and you actually divide with the new power, the new index at the bottom. Divide the function with n plus 1. And of course you add c because it's an indefinite integral. When you integrate cosine, you will actually get sine ax plus b, and you always divide it with the coefficient of x. Same goes with sine, but the only difference is you'll get the resultant as a negative cos ax plus b, and you divide it with coefficient of e. Please remember the signs correctly. And if you have a function in terms of ax plus b, this only applies to a linear function to the power of n. So you copy it back and you add the power here, n plus 1, and you bring the n plus 1 to the bottom and multiply it with the coefficient of x. And don't forget to add your constant for integral. Okay, now let's apply the rules of integration to integrate the functions below. Integrating 5x squared minus 8x plus 5 will result in, using the x to the power of n integration basics, 5x cubed, 2 plus 1 is cubed, over n plus 1 brought to the bottom, which is 3, minus 8x squared over 2, which will result in minus 4x squared. And a number 5, integrate a constant, will actually give you 5x. And because this is an indefinite integral, therefore you need to add the c. Applying similar rules for the next two functions will actually result as integrating this function will result in negative 6x power 4 over 4, which can be further simplified to negative 3 over 2 times x power 4. 9x cubed over cube, so will result in 3x cubed, plus 4x squared over 2, which can be reduced to 2x squared. Integrating a constant will again give you minus 3x. And don't forget to add a c because this is an indefinite integral. The next function, using similar rules, x to the power of 3 over 2, add 1 will become 5 over 2, divided by 5 over 2. When you divide with 5 over 2, you will get flipped. Multiply by 2 over 5. And integrating 2x gives you 2x squared over 2, which can be simplified to x squared. And integrating a constant gives you 3x. And don't forget to add the c because this is an indefinite integral. Integrating function such as 8 over x. Okay, this is a rule of thumb. When you integrate 1 over x, you will get ln x. So therefore, integrating 8 over x will result in 8 ln x. And integrating 5x over x squared, which can be written as minus 5x negative 2. So using the x to the power of n integration rule, this becomes negative 2 plus 1 will result in negative 1 divided by negative 1. So therefore, this can be further simplified to negative, negative, it becomes positive. So it becomes 5 over x. And integrating 6 over x cubed is actually integrating 6 over negative 6 to multiply by x negative 3. So therefore, this can be integrated such as 6x negative 2 over negative 2. So it will result in minus 3 over x squared. And of course, again, don't forget to add your c because c is the constant for the integration. for an indefinite integral. Same goes for the next question, next number 5. When you have surds, please write it in linear form first, as in change the surd to a number index. So x power of half, 1 over 3 multiply x to the power of negative half. This is basics of index law applied here. And then you can integrate. So x 1 over 2 plus 1 will result in 3 over 2 divided by 3 over 2. So when you divide it, it will flip to 2 over 3 multiplied by x power 3 over 2. Same goes for here. X power negative half plus 1 will give you x power half. And the 1 over 3 is a constant. We leave the constant in front here. Add the index with a 1, which will result in half, and bring the half to the bottom. Divide by n plus 1. So when 1 over 3 and 1 over 2 is combined, the resultant will be 2 over 3. X power half. And of course, don't forget to add the c again. When you have fractions as your index, please be careful when you add 1 to the index power. To avoid careless mistakes, please use calculator to do your calculation for the addition of fractions. So 3 over 4 plus 1, 7 over 4. And when you divide with 7 over 4, it becomes multiplied by 4 over 7. So 4 times 12 is 48 divided by 7. And for this, same rule applies. 5 over 3 plus 1 becomes 8 over 3. And you divide by 8 over 3, it becomes multiplied by 3 over 8. So 9 times 3 is 27 over 8. And of course, you add the constant c. When you have functions like number 7, you should actually simplify it to individual terms first. So as in x squared over x squared gives you 1. And plus 4 over x squared is 4x negative 2. So when you integrate this, integrating a constant 1 gives you x. Integrating 4x negative 2, it becomes 4x negative 1 over negative 1. So therefore, it's minus 4 over x and plus c. For question like number 8, you use index law and actually add the powers. So 1 plus half is 3 over 2 because it's at the bottom. So therefore, when you bring it up as linear function, it becomes x to the power of negative 3 over 2. And then you integrate this. Negative 3 over 2 plus 1, you'll get negative half. And you divide it by half, you actually bring negative 2 as the coefficient in front. And x power negative half becomes x, surd x, written at the bottom. And of course, you add c. For questions like that, you can't integrate it directly. You have to actually expand the question first. So you expand this function. 1 times t square, 3t plus t square, 3t cubed. And then you individually integrate it using the basic law of integration. So therefore, it will become t3 over 3 plus t4 over 4 plus c. For number 10, the function is a squared function. Therefore, you have to actually expand the quadratic function first. So when you expand this quadratic, it becomes a quartic function. So expand this using the normal expansion law. And then you will result in this. And then individually integrate each term. And of course, don't forget to add the c. For number 11, you actually have to combine the index first. So it is y squared and y to the power of 1 over 3. So 2 plus 1 over 3 is 2, 1 over 3, which equals to 7 over 3. And then you integrate y to the power of 7 over 3 by using the basic law of integration. So 7 over 3 plus 1 is 7 over 3 plus 3 over 3, which will result in 10 over 3. Divided by 10 over 3, it gets flipped 3 over 10, plus with c. For number 12, integrate d theta. This is as if it is integration of 1 d theta. So therefore, it is, when you integrate 1, you will actually get theta because the unknown here is with respect to theta. So it's the same if you integrate dx, you will get x. So when you integrate d theta, is as if you integrate 1 d theta, which will result in theta plus c, of course, because this is an indefinite integral. So integrating sine and cos, just a recap, when you integrate sine, you will get negative cos. Like number 13, 7 is a constant, just leave the 7 there. Integrating sine gives you negative cos x. So the resultant here will be negative 7 cos x plus c. For number 14, 5 is a constant again, just leave the 5 alone. Integrating cosine theta gives you sine theta plus c. So I'm very sure by now you have actually observed the changes from dx, dy, d theta. So all this means the y here means dy means integrate with respect to y, theta means integrate with respect to theta, x means integrate with respect to x, and so on. So please pay attention what is the function integrated against. Same goes with number 15, 9 sine 3x. When you integrate sine 3x, you get negative cos 3x. Negative cos 3x, there was a 9 here, it's negative 3 here, so something has happened in between. When you integrate cos 3x, when you integrate sine 3x, it will become cos 3x over 3. Because this is the reverse of differentiation. So cos 3x over 3, 9 over 3 gives you negative 3 because integrating sine is negative cos. Same goes here. When you have cos 4 theta, when you integrate cos 4 theta, you will get positive sine 4 theta divided by 4. So 12 divided by 4 is actually 3 plus c, of course. Same goes here. When you integrate cos 5x, 7 is a constant, just leave the constant alone. Cos 5x becomes sine 5x, of course, divided by 5. The coefficient of x is always divided by the coefficient of x. And of course, don't forget to add c. Same goes here. 4 sine x over 3 becomes, integrate sine x over 3 is negative cos x over 3. And it is divided by 1 over 3 because that is the value when you get, that is the coefficient of x here. So 4 divided by 1 over 3 actually gives you 12 plus c. Now you should apply all the rules that you learned in the previous slide and try to solve number 1 to 15 and compare your answers with the next slide. Number 13, 14, 15 and 8 require some simplification and expansion before you actually integrate the individual term. So make sure you apply the rules and try to integrate these functions. These are the answers applying the rule of integration from the questions from the previous slide. So please make sure your answers actually match these answers. Remember to try.